Okay, one bonus point to anybody who can name the character in this movie. Do you remember Thunderhead? Nookips. In this screencast 3.3, we will look at some key features of the periodic table and quiz you on them, because in screencast 6.2 we went over them. Hey, maybe you know them already. Let's go ahead and check them out. Alright, features. I'm going to point to a little spot. You tell me what it's all about. There's a group. Technically that would be a block known as the S block. If you quiz yourself on these, you'll do much better. How about over here? That's right, P block. 10 across must be the D block. And 14 across, that's right, the F block. Just some random letters used to assign these big groups. What about that column? It is the alkali metals. This one, similar name, alkaline earth metals. This one, that's right, the halogens. How about right there? Oh, very important, the noble gases. Okay, now let's answer some questions. We're going to go across and just fill in the blanks. Oxygen, is it a metal? Nuh-uh. Is tungsten? Yep. Is silicon? Best answer? Not no, not yes, but oid. Metalloid. Which block is it in? Oxygen? I think it's there. Looks like the P block. Tungsten, somewhere in here. Symbol W, weird, right? That must be the D block. And silicon, right under carbon, P block. How many valence electrons? In its uncharged state, oxygen must have 6. You could look it up on the class periodic table and just look it up directly, and it'll say 6 valence electrons for that whole column. Tungsten, well, all the metals have 2, but be careful, it's misleading because they have some unfilled inner shells. And silicon, just like carbon, has 4. Very versatile. The charge on oxygen, well, the charge, I think that means the charge that it would prefer to form. Oxygen would love to gain 2 electrons and form a -2 charge. It's become noble, like the noble gas neon. How about tungsten? It has 2 valence electrons, but you know it's in that multivalent region. I'm going to say it varies. And silicon, well, lots of answers possible there. Maybe under the right conditions it could form a +4. Maybe on the right conditions it could form -4, because it does have 4 valence electrons. It wants either 8 or 0, meaning the 8 from the one below it. But it could also share. Okay. What period is it in? That's the row. And they're just listed right there, so that's an easy one, isn't it? Oxygen, 2. Tungsten, find it. You'll see that it's 6, so it must be in this row here somewhere. And silicon, 3. Which one's the biggest? Well, I don't think we've taught it yet, but I might as well throw it right in. They get bigger towards francium, so if you draw a diagonal line from fluorine to francium, that helps quite a bit. And you'll find that tungsten is the closest, therefore tungsten's the biggest. Most electronegative, we haven't taught that yet, but let's throw it right in. They get bigger towards fluorine. Higher electronegativity, higher desire for electrons. Who's the closest to fluorine? It's got to be oxygen. And the most massive, that means the heaviest, that simply would be the largest average atomic mass. So look up these little numbers here and find out which is the biggest, and I believe it's tungsten. And there you go, some features about the periodic table, screencast 6.3.